Hi there, welcome to this video. So today I want us to discuss three questions from Mathematics Paper 1. I know you have a crucial time preparing for exams, your GC exams, your school certificate exams. So I'm here to help you prepare for exams. So I've prepared three questions that I want us to discuss. So let's just get started and answer the questions together. Okay, so the first question says factorize completely 27y squared minus 3x squared. Okay, so we want to factorize this expression. We want to express this expression as a product of its factors. So let's factorize this expression. So I'll start with number 1. I hope you're able to see this. Okay, so number 1 says factorize. This is 2 marks, by the way, in Mathematics Paper 1. So we want to factorize this expression. Okay, so what we have is 27y squared minus 3x squared. So let's factorize. So the first step that we're going to apply here is the basic method of factorizing. That is the common factor method. Okay, so I just want to see and be like, what is common there? So you can see that what is common is 3, because 3 can go into 3. It can also go into 27. Okay, so we take it out. So what we're going to have first of all is 3 outside. Then we divide 3 into these numbers. So 3 into 27, 9. Okay, because 3 times 9 is 27. So what we're going to have left there is 9y squared. Then 3 into negative 3. First of all, I put a negative there. Then 3 into 3 is 1. So what we're going to have there is 1x squared, or I can just say x squared, like that. Okay, and it makes sense. Okay, because if I take 3 out, I divide there, I have 9 there. Okay, if 3 is out there, you no longer have 3 there. Okay, so you're dividing there. What you're going to have left there is x squared. Okay, so at this stage now, I want you to be familiar with something called difference of two squares. Okay, I want you to be familiar with something called difference of two squares. Let me just explain this. So difference of two squares looks something like this. So you have a squared minus b squared. Okay, so according to this rule, every time you have two squares, okay, a squared, b squared, then in between them, there's a different sign, there's a minus sign. So what you want to do is this. This is what you want to do, okay? I want you to express this. You should always express this like this. For a moment, just forget about the squares. Assume they are not there. So if there are no squares there, you just want to write this as a minus b. Okay? Then repeat the same thing. Repeat the same thing, but with a different sign. So you're going to repeat the same thing, but this time around you're going to say a plus b. Okay? So it means that when I expand this, I multiply, I open the brackets, I'll still get the same thing. So every time you see a squared minus b squared, you should always express it as a minus b multiplied by a plus b. If you want, you can start with a plus b, then a minus b. It's the same thing. Okay? So if the examiner asks you to say factorize, maybe they ask you to factorize something like y squared minus 1. What do you want to do here? So you should always, once you see the square, you want to suspect that this could be a difference of two squares. What? Question. Then see, can I write this expression in this form? Okay, that's the first question. Can I write this expression in this form? Yes, we can, because this is the same as y squared minus 1 squared, because 1 squared is still 1. So it means that this can also be written like that. Once you write it in this form, then you can now just use this rule to write down the expression. So you factorize the expression like this now. So you forget about the squares for a moment. What you're going to have is y minus 1. Then repeat the same thing, but with a different sign. Okay? This is what we call difference of two squares. Just to give you another example for the sake of practice. Let's suppose we have this. We have m squared minus 9. M squared minus 9. So first of all, because there's a square and there's a minus, you're suspecting that this could be a difference of two squares. What? Question. Then the next question you're going to ask yourself is, can I write this expression in this form? Okay? Yeah. So let's see if we can write it in that form. So what we're going to have, this is m squared minus 9 can be written as 3 squared. So 9 can be written as what? 3 squared. So because you can have that form, it means we can now easily apply this rule and factorize our expression. So let's now complete our factorization. So we forget about the squares for a moment. M minus 3. Then what do? We repeat with a different sign. M plus 3. Then you are done. Okay? So let's go back to the question and see what we're supposed to do there. Okay, so this is the stage where we are. Okay? It's the same thing, just a little bit of some changes there, but it's the same thing. So because we have some squares there and there's a different sign there, we are suspecting that, oh, what we now have inside is a difference of two squares. It means that our factorization is not yet complete. Okay? So we need to complete our factorization. So let's now see what we can do. So 3, can I write every term there as a square? Okay, can I express every term there with a square? So let's see. These are already squares, but can I write 9 as a square? Yes, we can do that because 9 is the same as 3 squared, but it's multiplying y squared like that. Then minus x squared. Something like that. Now that everything has been written in this form, okay. In fact, you can actually, because you have 3 squared times y squared, if you want, you can put them together and say this is the same as 3y, then both are what? Squared, like that. So that you can easily see it as a squared if you want. But applying the same rule that I said, after you write every term with a square, just forget about the squares for a moment. What you're going to have is 3, okay? Then multiplied by what? If we forget about the squares, we're going to have 3y here minus x. Then what do? We repeat the same thing but with a different sign. So multiplied by 3y plus x. Okay, so you are done. That is how you would have answered this particular question. So this is our answer. This is our final answer. Okay, let's go to the next question. So the next question says a straight line L is represented. Let me just zoom in. Let me zoom out this part. I'll actually solve this here. Okay, a straight line L is represented by the equation 2x minus y equals 5. Find the gradient of the line. So we have this line, a straight line, that is represented by this equation. This is the equation of a straight line. Find the gradient of the line. So how do you find the gradient of a line if you are given its equation? Very easy. Let's do it. So you are given the equation of this line, then you want to find the gradient of this line. The first thing, let's bring it down. So we have this line, 2x minus y equals 5. Okay? So I want to introduce you people to the standard equation form of any straight line. Okay? So the standard form of the equation of a straight line looks like this. Y equals mx plus c, mx plus b, or kx plus b, whatever you are okay with. So y is equal to mx plus what? C. So this is the standard form of the equation of a straight line. So the equation of a straight line is given by this formula. Y is equal to mx plus c. Now let's define some terms here. What is m? What is c? Of course, y and x are just the values of x and y. There could be a point, maybe 1,2 like that. This is x, this is y. Okay? They describe what is the value of y when x is this. That is what we have. There could be a point. We could have a point there. Then m is simply the gradient of that straight line. The gradient of the line is m. Then c is the y-intercept, where this line cuts the y-axis. That is c. Okay? So meaning, for me to find the equation of this line, I just have to express it in this form. Because if I express it in this form, whatever will be in front of x That will be the what? The gradient. What is this? This is the y-intercept. Y-intercept. It shows where the line, okay, the line cuts the y-axis, where it passes through the y-axis. So for me to find the gradient of this line, because that's what the question is asking me, I just need to make sure that y is the subject of the formula. In other words, I want to express my equation in this standard form. Then I'll be able to see what will be in front of x. Whatever is in front of x, the coefficient of x will be the gradient of the straight line. So this question now it looks easy because we just have to make y the subject of the formula. How do we make y the subject of the formula here? Two ways. If you want, you can start with 2x, you take it there, but that would be too much work. So this is what I can do. I'll just take the negative y, take it that side. I want y to be alone. So because there's 5 there, I want y to be alone there. So I should also take 5 and bring it this side. So what are we going to have this side? So we're going to have 2x, 5 has joined. But here 5 was positive. So once it goes to the other side, it becomes negative. So it will be 2x minus 5 equals. Y has gone to the other side. But here y was what? Negative. It goes to the other side, it becomes what? Positive. So what we're going to have here is something like that. So 2x minus 5 is equal to y. If you want, you can look at this from the other angle like that. You can say, oh, this is the same as saying y is also equal to 2x minus 5. Someone can say 2x minus 5 is equal to y. Oh, y, you can read from that angle. Say y is equal to 2x minus 5, like that. Now, if we compare with our standard equation, you can see our standard equation is y equal to mx plus c. So if y is the subject, whatever is in front of x is the gradient. So here, what is in front of x? A 2. So it means that our gradient, therefore our gradient m is equal to what? 2. That is how you find the gradient. Okay, so let's go to the next question. Okay, so this is the third question and the last question in this particular video. Okay, so let's look at it and solve it together. The question says the first 3 terms of an AP arithmetic progression. Okay, arithmetic progression, AP. So the first 3 terms of an AP, this is a sequence, are 2, 5, 8. So we have a sequence. Yeah. The first question says find the 10th term. Find the 10th term. Okay, so we have this AP. Now what is an AP? An AP is a type of a sequence where the members in that sequence, the terms in that sequence, can increase by a constant amount, or maybe they can be reducing by a constant amount. Let me just give you an example for you to understand what I mean. Let us look at these terms. Let's say we have 1, then the next term is 3, then we have 5, then we have 7, then we have 9, then just like that. Okay, so let's see what's happening to the terms here. So each number in a sequence is called a term. Then the position of a term, for example, this one is in the first position, so we call it the first term. This is the second number, second term, third term, fourth term. So we can use things like T1 to represent first term. T1 is equal to 1. Sometimes we use A, mostly, if not sometimes, we mostly use A to represent the first term. So T1, or you can use A, here is what? 1. T2 is 3. T3 is 5. Just like that. Okay, so this will just show you, oh, which one is the first term? T1. Which one is the second term? T2, just like that. Yeah. Now, I want you to see something here. You can see that the numbers here are increasing. They are increasing. We are adding a constant what amount. That constant amount that we are adding there, if you can see this, is actually 2. Okay? So that constant amount added to the previous term to get the next term is called the common difference. Okay, so in an AP, we have what we call the common what? Difference. Common difference. So this common difference is simply the amount the numbers are increasing by or reducing by. We can also have a situation where numbers are what? Are reducing. Okay, imagine maybe I have this sequence. I have 5. Okay, then I go to 2, like that. Okay, then I go to -1, like that. Then I go to -4, like that. Okay, so what's happening to the numbers here? So from 5, I go to 2. There's been a reduction by what? 3. 2, I go to -1. There's a reduction again of what? 3. It's like 2 minus 3, -1. -1 minus 3, -4. So you can see that even here, the numbers are also reducing by a constant amount. So whether they are increasing by a constant amount or they are reducing by a constant amount, they all belong to what? This type of a sequence, arithmetic progression. So that amount they are reducing by or they are increasing by is called the common difference. If the numbers are increasing, then the common difference will be positive. But if they're reducing, then the common difference will be what? Negative. Okay. So for this particular AP, you can see that the numbers are what? What's the first term? We use the symbol A for first term. So A is equal to 1. Sometimes we can use T1. Okay. Then we use the symbol D for common difference. So common difference. To find the common difference, actually, you can say common difference is equal to the second term minus the first term. Or you can say the third term minus the second. Or the fourth term minus the third. Or term number 10 minus term number 9. So what I mean here is to find the common difference, you get the next term minus the previous term. The next term minus just the previous term. That's how you find the common difference. So in this case, our common difference D will be equal to 3 minus 1, which is 2. This number shows you to say, oh, they are increasing by 2. If you want, you can say common difference is this number, 9, minus this number, 7, 2. Okay? Yeah. Apart from finding the common difference, you also need to be familiar with how to find. For example, what if I ask you to say, what is term number 20 in this sequence? Of course, you can find term number 20 by adding 2, 2, 2, 2, 2 until you reach position number 20. But that will be so lengthy, okay? So you want to find a way now to get to that position, maybe in just in less than a minute, okay? Yeah, so we're going to apply something called the nth term, okay? So there's a formula for the nth term. So the formula for the what? For the nth term. So this formula can now can help you to find the number, the position of any term. Okay, you can find any term, whichever position you are looking for. So this is the formula for the nth term for an AP. So Tn is equal to A, which is the first term, plus N is the position. For example, if I ask you, what is term number 20, 20th term, then N is 20. So Tn is equal to A plus N minus 1, then multiplied by D. You need to know this formula, okay? So Tn is equal to A plus N minus 1 multiplied by D. This is the general formula for the nth term of any AP. That is how you find it, okay? Yeah, I'll also introduce another formula for the question that we have here today. But for now, let's go back to the question and answer it. Okay, so the first question says we have an AP, so 2, 5, 8. So this is an AP. How do you know it's an AP? Because the numbers are increasing by what? A constant amount, which is 3 in this case. And we call that constant amount a common difference. Yeah. So the first question says find term number 10, the 10th term. So somewhere we have term number 10. Okay, so how do we find it? Okay, so we're going to use the nth term. So we're going to say part 1 to find that 10th term, we don't want to start adding 3 until we reach, we're going to consume a lot of time, okay? Yeah, so we're going to say Tn is equal to A plus n minus 1 multiplied by D. Then we're going to substitute in. So what is our A? So A is the first term, which is 2. Okay? What is our D? D is the common difference, which we get by saying term number 2 minus term number 1. In this case, we're going to have 5 minus 2, which is 3. That is D. Then what is N? N is the position of the term we're looking for. So in this case, we want to find the 10th term. So N is 10. Okay. So with this data, we can now substitute in that formula. We said we are looking for term number 20. Term number 10. So term number 10 is equal to the first term, which is 2, plus, okay, like that. N, which is what? 10 minus 1, then multiplied by D, which is 3. Okay. So let's simplify. So we're going to have 2 plus 10 minus 1 is 9. So 9 multiplied by 3. We're going to have 2 plus, so 9 multiplied by 3 is 27. Then I'm going to add 2 plus 27 is 29. So that is term number 10. That is how you get it. Okay, so let's go to the next question. The next question says, find the nth term of the sequencing. Find the formula for the nth term of this sequencing. This nth term, this is the formula that we use to find the nth term, but this is the general formula for any sequence. We now want to find, we just want to simplify this formula so that it only applies to this sequence that we have. So if they ask you, find the nth term of the sequence, or find the formula of the nth term of the sequence, they're asking to say, simplify this one so that it only applies to this sequence. So how do we find the nth term? We know the formula. So Tn is equal to A plus n minus 1 multiplied by D. So we now substitute in with the information for this particular what? Sequence. So shall we say Tn is equal to A. We already know that A is 2. Plus n. We're finding this formula in terms of n. So n minus 1, then times D, which is 3. Then let's simplify. So Tn is equal to 2 plus this 3 will multiply whatever is inside there. So 3 times 3n, 3n. 3 times negative 1, negative 3. So we're going to have Tn equal to, so I can just collect the like terms here. So let me start with 3n. So 3n here is positive. Then I bring my positive 2 here. Then I have my negative 3 there, like that. Okay, so Tn is equal to 3n. Positive 2 minus 3 is negative 1, like that. So this is the formula for the nth term for this particular sequence. That is how you answer it, okay? But what does it mean? It means that this formula now is only applicable to this sequence that we have. We can now use this formula to find any term at any position, okay? For example, if you see in this question that we had, we said find the what? The 10th term. Now that I know that the formula that is specific to this sequence is 3n minus 1. This is the nth term for this sequence, okay? I can now use this nth term to find the position of any term, to find any term at any position. For example, here we wanted to find the 10th term in the problem that we had. Instead of using this long formula, I have now simplified this formula so that it only applies to this sequence. So I can say term number 10 here will be equal to 3. We said n is the position, so 3 times 10 minus 1. Then 3 times 10 is 30 minus 1. This gives us what? 29, which is equal to the answer that we got in part A. Okay, so this is how you use it. For example, I want to find term number 100. Term number 100. Using this one will be very easy. Okay, yeah. Term number 100 will be equal to, I just use this one, 3 multiplied by 100 minus 1. I know that 3 times 100 is 300 minus 1, what do I get? 299. Okay, so that is what we mean by nth term of the sequence. Okay, so let me just get rid of this stuff. Okay, so the next question says the sum of the first 20 terms. So sum of the first 20 terms, sum is the answer that you get when you add terms, right? Yeah. So that is sum. So by sum, we want to add these terms. Okay, let's add these terms. We want to form a series, an arithmetic series. So when we say find the sum of the first 20 terms, we mean we want to add from term number, we want to add term number 1 plus term number 2 plus term number 3 all the way up to term number 20. We want to add all these. Now, are we going to manually add them like this? Term number 1, am I going to find all the terms and add them? No, we're going to apply a formula. Okay, so this formula can now help us, but you should know the physical meaning. The physical meaning implies that we are adding all these terms. We have a span of terms. Okay, so we have these terms that we are opening up, and we're adding them together, and you're getting the sum of the first 20 terms. So let's apply the formula that can now directly help us to find the sum of the first 20 terms. Okay, so to find the sum of the first any terms, the sum of the first any terms, maybe 10 terms, the first 10 terms, the first 15 terms, the first 20 terms, whichever, the sum of the first any terms is equal to n over 2, okay, multiplied by 2a plus n minus 1 times d. Okay, so this is the formula. So the sum of the first n terms is equal to n over 2 multiplied by 2a plus n minus 1 times d. That is how you find the sum of the first n terms. So in this case, we want to find the sum of the first 20 terms. So because we're finding the sum of the first 20 terms, it means our n is equal to 20. We already know what our a is 2. We know what d is 3. Then we substitute them there. So sum of the first 20 terms is equal to n is 20 over 2. Then multiplied by what? 2a. A is what? 2. Then plus n. You can see there, n is 20. We're talking about 20 terms here. Minus 1 times d. Oh, sorry. Times d. D is what? 3 there. So we just simplify that now. So let's start. 2 into 20, 10. 2 times 2 there, 4. Plus 20 minus 1 there is 19. Multiplied by 3. Okay, we're almost there. So 10, 4 here. 19 times 3, 57. Okay, so you multiply 19 times 3 is what? 57. So plus 57. You can take your time there and multiply. Okay, then 4 plus 57, 61. But remember, there's a 10 outside here. Then what will happen here? 10 times is 61. What are we getting? 610. So the sum of the first 20 terms here is 600 and what? 10. Like that. Okay. Now, there is actually another formula that you can apply to find the sum again. So, apart from this formula, you can also use this one. The sum of the first n terms. This one you can apply this formula when you know the first term and the last term. For example, if I want to find the sum of the first 20 terms here, I want to know what is term number 20 and term number 1. So if I know term number 1 and the last term, because here we were adding all the way up to term number 20. So if we know term number 20, we can now use this formula. So sum of the first n terms will be equal to n over 2, the first term plus the last term. Okay, so we can apply this one. Now, in this case, we didn't calculate, we don't know what term number 20 is. But we can actually find term number 20. We know that Tn is 3n minus 1. So let's first of all find the last term, because the last term is term number 20. So T20 is equal to 320 minus 1. So 3 times 20 is 60. 60 minus 1, 59. It means that our last term there, when we are adding this, the last term is 59. Then we can apply this. We shall say sum of the first 20 terms is equal to n20 over 2. First term, a, 2. Remember our first term is 2. Plus the last term, we are ending up to 59. That's the last term. So we're going to have 2 into 20, 10. 2 plus 59, 61. So you can see that we're getting back to the same thing there. Okay, so 10 times 61, we're getting what? 610. Okay, which is in line with what we actually just got here. So whichever method you want to use, it's up to you. Okay, but you need to be very careful when you are using this one. You want to find the last term there. Okay, so I think this is what we have for you today. And if you found this video helpful, you know what to do. You want to leave a comment there, and you want to subscribe to this channel so that you don't get to miss on any of our videos. Otherwise, bye-bye.